All right, I got it going. All right, so we're looking at the Pythagorean triples. Boom, there they are. I just showed the camera. That's why I said boom there. All right, so why do we use it again, Armada? What did you say?
To save time.
Okay, it can help us save time. Sometimes it can help us save a lot of time. All right, now, if I ask you to find the missing side in a triangle, and you recognize that it's one of the Pythagorean triples, you don't need to do the Pythagorean theorem. Right? So, what do the Pythagorean triples relate to? Where do they even come from?
Similar triangle.
Okay, yeah, we had similarity last unit, and now all the triangles that have the same ratio are similar to those families. So what you want to do, try to see, does this belong to one of the families? How do we do that? Then how do we use that to find the missing side? Somebody explain. How are we using the Pythagorean triples? Now, don't everybody volunteer at once.
You're gonna have to repeat that.
Repeat what?
The course.
Okay, how about I just start a whole new question? Tell me how to get this.
Okay.
Sophia. Or which ones of those go into that? It could go either way, yes. And then how do I figure out which one of these go into those? Okay, yeah, so the hypotenuse always has to be connected to one of those because those are also the hypotenuses, right? Okay. Okay, now, yes, but I kind of tricked you in this one. I didn't draw the triangle to scale. So this, in my problem, is not the smallest side, or is not the medium side. It actually, I made it the smallest because I'm a jerk and I wanted to try to trick you. Because I wanted to see, right? Because if this was the medium side, there's 4 going to 21, there's 24 going to 21, there's 15 going to 21, there's 12 going to 21, none of those going to 21, right? Okay, yes, because what you can always do is check, if I give you the hypotenuse, is check the hypotenuse. Does 5 go into 75? Yeah, 5 times 15 is 75. Well, is this 4 times 15? Is this 3 times 15? So none of those work, right? So now, does 25 go into 75? Yeah. Okay, 25 times 3. 24, no, 7 times 3, right? So 7 times 3, 25 times 3. So this is going to be 24 times 3, and we get 72. Now, see what I mean, how I tricked you? Shouldn't that one be the 72? It's not drawn the scale, right? Okay. Now, you can use the Pythagorean triples to find that missing side. Now, if we didn't know that, we didn't know the Pythagorean triples, this could take you a longer time. I'm going to put an X there. Now I got to go X squared plus 21 squared equals 75 squared. So instead of using knowledge that we have from last unit, now I got to just use the Pythagorean theorem because I failed last unit. Or, no, okay, or never mind. Let me, damn. But now I got to know like how to do, like I better have a calculator, right? 21 squared, 75 squared. Then I got to punch that all in. So I'm going to get X squared. What's 21 squared?
441.
Are you lying?
I did it actually.
441. What's 75 squared?
565.
565. Now you got to subtract 441 from both sides. What?
565.
That doesn't make sense.
5,625.
You got to subtract from both sides.
Wait, what?
This is 5625. Oh, this is 562.
Yeah, that is fast.
Okay, what are you talking about? All right, now subtract 441 from both sides. Let's go. Calculator people.
5184.
Yeah.
5184?
Yes.
See how this, I don't like doing it. Again, who could do this math? Oh, X equals the square root of 5184.
Squared is 72.
And I guess you could just punch that in your calculator now, huh? Because it's a perfect square. The square now. 72. Okay, so we gotta do a little extra work. We gotta have our calculator. We didn't even need a calculator to do it before. Okay. All right, now, it can even help us more when we've got some crazy signs.
What? Five and 12.
What?
What do you mean it's just 5 and 12?
Never mind that.
Is this a triple?
Yes.
Which one?
5, 12, 13.
Okay, so if one's 5 rad 2 and the other side's 12 rad 2, what's the hypotenuse?
13 right.
13 rad 2. That's not bad at all. 5 rad 2, 12 rad 2, so 13 rad 2. Why am I so extra?
Yeah, why have the red two? You need to be there.
Well, 5 rad anything. 5 rad Jesus. There we go. This is 12 rad Jesus. This is 5 rad Jesus. So this is 3 rad Jesus, right? Doesn't matter. Okay, it's just a factor of all of them. They're all the same thing. All right, can I put 2 back in there? Now, if we didn't know the triples and we had to find that missing side, right? We're now doing operations with all these radicals. 5 rad 2 squared plus 12 rad 2 squared equals c squared. Now, I know you can punch this in your calculator and get an answer, but who knows how to punch it in the calculator the right way? You got to use parentheses? You know how?
Math way.
Okay, right? Or what's 5 rad 2 squared? What if this was a non-calculator portion of a test? What's 5 rad 2 squared?
5 rad 2 squared.
Or do you change it into?
25 rad 4,
That's what I was gonna say. Yeah.
Which
hold on.
is-
Give me a moment to process that.
50. 5 rad 2 squared is 5 rad 2 times 5 rad 2.
What's 5 rad 2?
5 times 5 is 25. Rad 2 times rad 2 is rad 4. Rad 4 is just 2, 50.
Wow.
Wow.
Would you guys rather just use the Pythagorean triple families or doing all this, right? Okay. So again, just showing why it might be good to memorize those. Just saying. 12 rad 2 squared.
Oh,
What's 12 squared?
oh no.
144.
And then,
Square root of 2 squared is square root of 4, which is
wait.
2. Oh, look at you guys. You can't even do it in your head.
There's
Okay, let's
so
write it
many
down.
things that are wrong.
It's 288. Oh, here, I think it's 288. 12 rad 2 times 12 rad 2.
You
We
said
get
so many words.
we
and
get
none of them make sense.
144 rad 4, which is 144 times 2, which is
288.
that's what I said.
You weren't even speaking.
You just
You were
there.
like, what's the square root of 2? And we were like, we don't know. You weren't asking us
Yeah,
what
you
that
were-
was.
Yeah, man.
I'm just saying.
He's like, I don't know.
What is this? 338? Who knows how to take the square root of 338?
Calculator.
The 15, 16.
16 is the square root of 338?
No.
Okay, we can't leave it as a decimal, though. We gotta leave it as a simplified radical.
Okay, what's the number to multiply with 338?
Yeah, I know the answer is 13 rad 2 because I already did it. 5 rad 2, 12 rad 2, but how do we get it from here? Yeah, just punch it in your calculator. What if it's the non-calculator portion of the test?
Well,
Cross factor.
Wait a minute, is there gonna be a non-calculator portion?
36.
Are you giving us a non-calculator?
169 times 2. Why are you like this?
That's everybody's like that. Wait till you get into pre-calc and you have the calculator portion and the
This
non-calculator
is not
portion.
Until I
recalc,
drop the high
though.
When is that?
This is
Wait, that's not
recalc.
next year. Hold on. Oh, you gotta have 2 years before that. Algebra 2 next year, then pre-calc.
No, no.
You don't want me to prepare you for the future, Daniel?
No.
That's my whole job.
I won't be a math major, so it won't matter. I'll be something else besides a math major.
All right. Okay, then what do we do here? This is what, this is the square root of 169 times the square root of 2. Okay, boom, 13
How
right
did you
2.
know 169?
Because I know math. All right. Okay, we don't know, right? We don't know. 338. So we're gonna do what? Let's go 2 times what? Break it down. Prime factors. 338 divided by 2.
Wait,
Oh my gosh.
Yeah.
I just did it in my head over here, but now I don't know how to do it over here. 169. All right, well, this is 2 times, this is a stupid example, 13 times 13. Pull out the pair of 13s, put it in front. That was a stupid example. Well, whatever.
Example.
I just took like 25 minutes explaining why we need to maybe use or know the Pythagorean triples.
So useful.
Yeah.
Okay, now the Pythagorean triples don't always help. Well, I shouldn't have said that. But I didn't want you to do this whole problem. Oh, no, never mind. Do the whole problem. Ready? What are you talking about, Mr. Sotowski? My brain's working faster than my mouth today. Sorry. Ready? Is everybody done?
What?
Everybody done with this problem?
Yeah.
Hold on.
No, you're a liar.
Everybody's done, right?
No.
No.
Oh, this is not.
What do you mean? 8, 15, 17.
Yeah, no, because 17 is the.
Oh, I can't trick you guys, right? 17 has to be the hypotenuse. There was one like this in the assignment yesterday, you remember? Okay. This one, Sophia said it earlier, this one has to be the hypotenuse.
Yeah.
In this case, it's not the hypotenuse. The hypotenuse can't be shorter than the leg. So now I don't know this side. If I don't know the side and it's not a triple, well, then you have to use the Pythagorean theorem. Now we have to go 8 squared plus 17 squared equals c squared and go through the steps in order to find the hypotenuse.
64.
You want to do it?
8 times 8 equals
64, 289,
okay, thank you so much.
c squared. Yeah. We'll keep going.
Yeah, and then you.
Finish it.
Add it together. I can't add. I can only multiply in my head. That's why I don't split the checks.
Hold on. I gotta get
353? That kind of sounds prime.
That doesn't
2,
make
8, 9.
Yeah.
Plus 3, 4.
So it's just the square root of 353?
You just learned that.
Just learn what?
You just learned how to simplify radicals. Actually, no, it's fine. Never mind.
But you can't simplify prime.
Because you can. I mean, unless you take 1 and 153, but that doesn't make sense.
Right. That's prime. Okay. Now Pythagorean theorem, that's Pythagorean triples. We'll have some like application type problems, right? So we can have a problem like number 4, find the length of the altitude. Wait, you got to remember stuff from the last semester?
90 degrees.
What's an altitude?
90 degrees.
Altitude. I don't.
90 degrees.
What do you mean 90 degrees?
Yeah. What do you mean?
I don't know. It's not option 1.
What's an altitude?
Oh wait, I know that. Oh, you find the length.
Oh,
I know
isn't
what
it
it
from
is.
the point up there to the middle, the midpoint?
Then it makes 90 degrees.
Well, in an equilateral triangle, it does go to the midpoint, but that's not the definition of an altitude. Altitude does what?
Splits the triangle. Perpendicular. Never mind.
What do you mean by perpendicular? I need another word, more words.
Perpendicular to the.
Okay, it's perpendicular to the, okay, it's a segment from the vertex perpendicular to the opposite side. Now, what's gonna happen is all this right triangle stuff that we're learning, we're gonna start using in new units. Like the next unit is on circles. There's right triangles and circles, right? We can have like a circle and we've got a right triangle. I need to find the radius, or maybe I have something like this and I know that, and we can use the right triangle. So right triangles are going to be applied to that. We're going to have an area and volume unit. Well, in order to find the area of something, you need to know the height. Well, just like in a triangle, the altitude is the height. Or maybe it's a pyramid that we're looking to find the volume of. We need to know the height of the pyramid. All that stuff is related to right triangles. So we're learning the right triangle stuff now. and we're gonna be able to apply it to things later. Right now, we're going back and applying it to something we knew before, an altitude. Altitude, look at, this is in black, this is blue with a black pat mark at the top. Who did that? Me. Look at, this one's blue with a purple cap. Who did that? Me. You gotta keep it going. All right, there's the altitude. Vertex perpendicular to the opposite side. Oh my gosh. What did we draw?
All right.
A right triangle.
We don't have the other 90s.
Now, if you remember the triangle unit, an altitude of an equilateral triangle is also a median. So what is a median? That means this is going to the, it bisects it. This point is the midpoint. So this is congruent to this. So what's this? If the whole length is 40,
But you just gave
Oh, it's an equal level.
then this is 20. Yeah, I marked them all congruent. So this is 20. Now, I know this is 20 rad 3. I already know it. 20 rad 3. A equals 20 rad 3. Why am I such a nerd? Yeah. How do I know that? Well, this is another special triangle like those. You guys don't know that yet, but you're going to learn it tomorrow. So tomorrow you'll learn how to just go, oh, if that's 20 and that's 40, that's 20 rad 3. Today we don't know that. Today we have to use the Pythagorean theorem. Here's our right triangle. Did I just put this black marker over there? Where's the one that works? I need another marker.
Maybe you should have mixed
Purple.
your marker.
Give me purple.
There's a red one there that works good.
Yeah, all my markers did work. What?
Didn't work.
Did work good. And then like we got students drawing entire murals on the board over there. When did that happen? When I was in the bathroom? Like in between periods?
Oh, I wrote one though, but
That's actually a pretty good picture. It makes me happy.
I have no idea.
Fish, sun. It looks like spring.
Is it like spring in like 50 days?
So we got,
I told you.
Throw
the
it
red one
out.
did. The red one works great.
Why do you keep it if it doesn't work?
well, here, I'll just put all the markers like this, let gravity take effect.
Connect all the markers.
Yeah, here we go. 20 squared plus a squared equals 40 squared. So we're punching it in the Pythagorean theorem. We're gonna get 400 plus a squared equals 1600. Subtract 400 from both sides. So a equals the square root of 1200. Oh, wait, I already did that part. No, what are you talking about? He says, don't talk while I'm talking. You messed me up. Okay.
I messed me up too.
Square root of 1200. You said 800. I'm like, wait, I gotta subtract 400 again?
Wait, no, I just didn't know math.
Okay, me either. All right. Square root of 1200. You guys got a perfect square factor that goes into 1200? I know 100 does. 112. Square root of 100, square root of 12. That's 10 rad 12, but I'm not done. Because that has square root of 4. 10 square root of 4, square root of 3. So square root of 4 is 2, so this is going to be 20 rad 3. Oh yeah, that's what I said earlier, 20 rad 3. Remember? I remember. Okay. So we're doing the Pythagorean theorem. We need to know how to use the Pythagorean theorem, when to use it. But like I said, tomorrow we'll be talking about this special triangle right here, and you'll be able to find that missing side just as fast as I did. Dan, sorry, I skipped a step because I'm trying to speed up a little bit. The square root of 4 is 2.
Oh.
So 2 times 10. Okay. All right. One more example. One more application problems. Then I'm going to hand back your test. You guys can look at those, and then you're going to be. I'll have some practice problems for you to work on. All right. Ready? What's up, Oriana?
Never mind, keep going. I'll tell you later.
You walk to school?
No.
You don't?
No.
Who walks to school?
Actually,
Rian, you walk to school?
I live over there.
Okay.
Damn, that makes
So
sense.
Rian lives over there, right here. Here's Rian. Okay. Is that how you spell your name? 2 N's?
Yeah.
Bam.
Wow.
I know. And you walk to school.
Wow, that's really far. That is not
So
fair.
we'll just do it by blocks, right? So you probably walk You probably walk like 5 blocks north, then you walk like 7 blocks, never east, east, 7 blocks east, right? Then you probably walk like you walk like another 9 blocks north. Then you walk like 12 blocks east, and then you walk like another 2 blocks north, right? That's how many blocks you walk? Yeah, see, I know, right? Because he has to walk like this, because there's houses here, right? There's house on this corner, there's house, these are the streets, right? He's walking down the streets. Now, Rian, if you're late for school, right? Rian, if you're late for school, you're not gonna do that, right? You're gonna take a shortcut, you're gonna cut through everybody's backyards, right? So instead of doing this, he's just gonna do that. Bam, right there,
All the dogs are barking.
right? Yeah, dogs are barking, your hopping fences, bam, right through there. So if Rian does this, oh my gosh.
Throw it away.
If Rian does this, the students need to stop using my markers.
There's a name that happens to be really.
Okay. How far does he have to travel? Or how much shorter is it from the original distance?
So we know it's less than whatever all those numbers. That's all I know.
It is like the shortest distance between 2 points is a straight line.
Yeah, but like, you get shorter than what times with 11.
Let's think. What is this unit on?
Altitude. Triangles.
Pythagorean theorem. Right angle. So let's make a right triangle.
Oh, I see 2 right triangles.
Well, you could have a bunch of right triangles, but like, what about that one?
That's not counting.
What about that one? What about this one? What's that? Why not? Why don't we
Why don't we?
just figure out how far he went east and how far he went north?
Oh, it's
7 plus 12. He went 19 miles east,
and then
and he went 14 and 2, 16 miles north.
Wait,
Oh,
So
and then
2
we add
plus
it.
9 plus 5,
up and down.
7 plus 12, and then we can get the diagonal distance.
So it's like-
Now we just use Pythagorean theorem. 19 squared plus 16 squared equals the distance he traveled squared. What's 19 and 19? 361? 381? Sorry, what? 361? 361 plus 256 equals c squared. A little more help, Hamza? Let me some addition here. 7, 11, carry the 1, 617. 617, square root of 617. Now, we're talking about distance. I actually kind of want to know how many blocks it is. So give me the decimal. What's the square root of 617? 24.84.
No, 8.
Okay, C is approximately 21.8?
24.89.
24.8. So if he goes on a straight line, that's 24.8 instead of 12 and 9, which is 21, and 12, which is 33, 35. So normally it takes him 35 blocks. Now we have to go 24.8 blocks. It's 10.2 blocks shorter. Straight line style.
That's like
Wait, how many blocks?
4
are we saying?
miles.
Well, or if we're talking about miles, or right, that's almost 11 miles, right? Okay.
yeah,
You
no,
can
I
do that in a day.
Or
A little
11
over 10 miles. Okay,
8 blocks.
you don't walk that far, that'd be a long time.
Yeah,
Maybe ride your bike that far.
no, I don't.
Blocks, how long is a block? Like,
Block?
It's like,
is there like a
8 blocks
specific
is-
time, like length?
Honestly.
8 blocks is like a mile, right? Yeah.
Yeah, I heard 8 blocks.
So 8 times 4 is, that is 4 miles.
That's a lot of blocks.
Okay, so you guys have some application problems to work out in the packet. It's number 7 through
About 300.
7 through 13. What is it? Typically, a block is about 300 to 325 feet. Okay.
And then just the multiplication. and division.
So divide 5,000. What's a mile? 5,120 divided by about 300. 500.
And then
Okay, sorry, I'll write it on the board. I don't need this anymore. You don't need this anymore. Yeah, I'll hand back the test too.
Oh,